Welcome students. Measuring space, perimeter and area, exercise 6.3 solution. First question, find the area of the sector of circle with radius 7 centimeter if the angle of the sector 60 degree. So visualize everything so easily we can find the answer. 60 degrees, so the sector is the minor sector. So this sector, if we are joining this, the sector is minor sector. The angle here 60 degree given and radius 7 centimeter given. We need to find area of the sector. The information given, R is 7 centimeter, theta angle 60 degree. We know very well area of the sector is equal to theta by 360 degree pi r square. So replacing our particular informations here, theta by 360 into 22 by 7 into r squared. Don't write 7 squared. Instead of that, write 7 into 7. Then you can get the error-free calculation here. If you are finding r squared 49, then cancelling with 7, you will be wasting your time. So write r squared as r into r, 7 into 7. When you are cancelling this 6 times, 2 table 3 times, this is 11. Now we are having 11 into 7 in the numerator, 77, only 3 in the denominator. Dividing this, we will be getting 3 2s are 6, remaining 1, 3 5s are 15, remaining 2 by 3 centimeter squared or square centimeter is the area of the area of the sector. Second question, find the area of the quadrant of a circle whose circumference is given. So take a circle. In this circle, if we are drawing two diameters, this is one diameter, the diameter will divide the circle into 4 quadrants. Quarter part of a circle is nothing but quadrant. So here you can see 4 quadrant. Now you know area of the circle. Area of the circle pi r squared. So area of the quadrant 1/4 of pi r squared, because 1/4 of the this is center r, means the total area of the circle is pi r squared. So quadrant area pi r squared by 4. 1/4 of area of the circle is area of the quadrant. Now the angle at O in each quadrant is 90 degree. So if we are taking quadrant angle 90 degree, then also we are getting area of that quadrant, that sector is nothing but 90 by 360 pi r squared. So cancelling this, we will get 1/4 of pi r squared. So say that is the area of the quadrant. But here the radius or angle, nothing is given. The word quadrant is given. With that we can conclude the angle is 90 degree and circumference of the circle is given. So circumference of the circle 44 centimeter. Why this is given means directly the radius is not given. Here the circumference of the circle given. You know the formula of circumference of circle, which is 2 pi r is equal to 44 centimeter. Using this, we have to find the radius of the circle. So 44 centimeter, 22 into 2, 44 by 7 r is equal to 44. While transposing 44 by 7 to next side, already 144 there, and reciprocating the 44 by 7 as 7 by 44, we can cancel. Our R is 7 centimeter. So radius of the circle is 7 centimeter. That is the radius of the quadrant. So area of the quadrant. Area of the quadrant is equal to 1/4 of pi r squared. So 1/4 of 22 by 7 into 7 into 7. As I told you, don't write 7 squared, write twice. Then cancel it easily. 1 7 cancelled. Now 2 table 11 times, 2 times. Now 11 into 7, 77 by 2. When we are dividing 77 by 2, 3 times 6 remaining 1, 8 times 16 remaining 1, 1 by 2 centimeter squared, or else we can write 38.5 square centimeter is the area of the quadrant. Third question, the length of the minute hand of a clock 7 centimeter. Find the area swept by the minute hand in 10 minutes. So we're going to take a clock, circular shaped clock. So consider this is a circular shaped clock. Here we will take minute hand. Suppose this is our minute hand. Okay, this is minute hand. Now the numbers here 12 and 1, 2, 3. But now after 10 minutes, the minute hand will move to facing 2. Now after 10 minutes, the minute hand will move like this. This is the movement of the minute hand. So it moved from here to here. So this shape is, because the circular shape clock, this shape is sector. So here theta, we don't know what is the angle. We don't know that. This is the center. But we know at the center, the angle is 360 degree. With that, we can find theta. And minute hand, length of the minute hand is given 7 centimeter. That is nothing but radius of the sector. Length of the minute hand is the radius of the sector. So, length of the minute hand is equal to R is equal to 7 centimeter. That is the radius of the sector. To find the angle, we know that whole angle at O, the whole angle is 360 degree. So when the minute hand covers this 360 degree, after one full rotation, it will cover 360 degree. The full rotation, it will take 1 hour. That is after the movement of 1 hour, it will cover 360 degree. 1 hour is equal to 60 minutes is equal to 360 degree. So 1 minute is equal to 360 divided by 60 is equal to 6 degree. So 1 minute, the minute hand can cover 6 degree. So 10 minutes it can cover. 10 minutes it can cover. 10 into 6, 60. This is our theta. So the angle here the angle we got 60 degree. So swept 10 minutes, the minute hand can cover 60 degree. for 1 minute it is moving 6 degrees. So for 10 minutes 60 degrees. This is our theta. So area swept by the minute hand. Area swept by the minute hand is equal to theta by 360 into pi r square, 22 by 7 into 7 into 7, cancel 7 and 7, 6 times 3, 11, so 77 by 3, 3 2s are 6, remaining 1, 5, 15, 2 by 3 centimeter squared. So the minute hand can cover 25 2 by 3 centimeter squared area. Fourth question. The chord of a circle of radius 10 centimeter subtends 90 degree at the center. Find the area of the corresponding minor sector. In bracket it is given subtends 90 degree at the center and major sector subtends 270 degree at the center. So you know very well which is minor sector and which is major sector. This is minor sector one side and major sector another side. Here, this is minor sector. This portion is minor sector. The angle given here 90 degree. This portion minor sector angle 90 degree and this is our major sector. This is major sector. So the angle here given is 270 degree, that is 360 minus 90, 270 degree. Major sector angle 270 degree, minor sector angle 90 degree. Totally we are getting 360 degree. First subdivision, both because radius is common, radius is 10 centimeter given. First subdivision, minor sector. So for minor sector, angle is 90 degree. So it is a quadrant. Area of the quadrant or sector, whatever it may be, 1/4 pi r squared, 22 by 7. Rather using 22 by 7 because 10 is there, no, we can use 3.14 for pi value. For our pi value, in question itself it is given, use 3.14. Then our calculation will be very easy. 10 into 10. So 1/4. When we are multiplying 3.14, 10 into 10, our decimal will move 2 decimal digits right hand side. So 1/4 into 314 centimeter squared. So we are dividing this by 4 table. 7 times 28, remaining 3, 8 times 32, then remaining 2, 2/4. It can be written as 78 1/2 centimeter squared or 78.5 square centimeter. That is the area of the minor sector. Next we need to find area of the minor segment. This is area of minor sector. Now, second subdivision, major sector. Major sector angle is 270 degree. The same formula, area of sector. Don't use quadrant formula. Here area of sector 270 degree divided by 360 degree into 3.14 into 10 into 10. So 0, 0 cancel, 9 table, 9 3s are 27, 9 4s are. Now 3 by 4 into 314. So when we are dividing 314 by 4, already in previous question we got no 78.5. So 3 into 78.5 centimeter squared. When multiplying this, 15 remaining 1, 24 plus 1, 25 remaining 2, 21 plus 2, 23 centimeter squared. 235 centimeter squared area of the major sector. Here area, the angle of major sector, this angle is given here 270 degree. If it is not given also, we can subtract 360 minus minor sectors angle, we will be getting major sectors angle. If suppose it is not given, we can subtract and find. Thank you. The question, a chord of a circle of radius 15 centimeters subtends an angle 60 degree at the center of the circle. Find the area of corresponding minor and major segments of the circle. Use pi as 3.14 and root 3 as 1.73. So let's draw the circle. This is the circle. Here we'll take a sector, minor sector. Chord is nothing but the points, opposite points on the line segment joining opposite points on the circle. That is the chord. Now, if we are joining this two, we will be getting a chord. So this chord, this is the chord. Say the chord name AB. So this is the chord. AB is a chord. The angle, the chord subtends an angle 60 degree at the center. So this is 60 degree. Then radius 15 centimeter, 15 and 15 centimeter. We need to find area of the segment. So which is the segment here? This is area of minor segment. This green color line, this portion is segment is nothing but the area bounded by a chord and the arc length. So that is our minor segment, and this is major segment. This portion is major segment. So how to calculate this area? There is no separate formula to find the segment. So what we will do, we know the area, we know to find area of the sector. Here the segment is part of a sector, where if we are subtracting area of the triangle from the sector, we will be getting segment area. So we know very well area of the segment. Area of segment. Minor or major, corresponding one, if I am finding minor, area of minor segment. If suppose I am going to find area of minor segment. Area of minor segment is equal to area of minor sector minus area of corresponding triangle. Now here the triangle is AB, say our center point is O, this is O. Triangle OAB, what type of triangle OAB? This is OAB. What type of triangle? This is 60 degree. At O we got 60 degree. Then 15 degree one side and another side also 15 degree, because OA is equal to OB, radius of the circle, both are same, which means the opposite angles are angle A is equal to angle B. Angle A is equal to angle B. So one angle is 60. If we are subtracting angle, sum of a triangle is 180. 180 minus 60, we will be getting 120. This 120 degree equally divided for A and B. So A also 60. Angle A is equal to 60 degree. Angle B is equal to 60 degree. So OAB is an equilateral triangle. OAB is an equilateral triangle because all the angles are 60 degree. We know very well the area of equilateral triangle, root 3 by 4 side squared. So area of the sector theta by 360 pi r squared minus root 3 by 4 a squared square units. Here R and A both are same. R is equal to radius of the circle is nothing but side of the triangle. Both are 15 centimeter. So when we are finding that, replace 60 by 360 into 3.14 into 15 squared minus root 3 by 4 into 15 squared centimeter squared. If you are calculating very well, directly you can take the common number outside and calculate. Otherwise, go with separate method. That is, I am going to find first area of the sector. Area of sector is equal to 1 by 6. 360 by 60 is 1 by 6 into 3.14 into 225. 15 squared is 225. When we are cancelling with 2 table, 3 time and 1 time, remaining 1 5 times, remaining 1 7 times. Now we need to multiply 225 and 157. Then we have to divide that by 3. So 7 5s are 35, remaining 3, 14 plus 3, 17, remaining 1, 14 plus 1, 5. Then 5 5s are 25, remaining 2, 10, 2, remaining 1, 10, 11. Then 5, 2, 2. 5, 12, 13, 5, 3. Now after 2 digits we need to keep a dot. This is nothing but here we are getting 353.25 divided by 3 centimeter. When we are dividing this 1 time 3, then 1 time divide this and this, 1 time 3 remaining 2, 7 times 21 remaining 2, again 7 times 21 remaining 1, 5 centimeter squared. This is area of the sector. Next we need to find area of the triangle. Now area of triangle, equilateral triangles, root 3 value is given 1.73, root 3 by 4 into 15 square 225, which is equal to 225 into 1, calculate 225 into 173. So 15 remaining 1, 6 plus 1, 7 and 6. Then 7 5 is 35 remaining 3, 14, 17 remaining 1, 14 plus 1, 15. Then 5, 2, 2. So 5, 12, 14, 19 remaining 1, 6, 7, 8 and 3. Here also after 2 digits we need to keep a dot. Now we are getting the answer here 389.25 divided by 4. When we are dividing this, 9 times 36 remaining 2, 7 times 28 remaining 1, 3 times 14, 3 times 12 and 1 time 4 remaining 1, 2 times 8 and 5. So the centimeter square. This is area of the triangle. Now area of minor segment is equal to area of sector 117.25 minus area of triangle 97.31. Approximately we can take squared. So when we are subtracting this 117.25, then 97.31, we are getting 4, 9, 9, now area of minor segment, area of minor segment is equal to area of sector, which is minor sector, minus area of triangle. So here we got area of sector. This is area of sector 117.75 minus this is area of triangle 97 point approximately 31. So 117.75 minus 97.31, 4402. So we are getting 20.44 centimeter squared as area of minor segment. Next we need to find area of major segment. So except the minor segment, the remaining portion fully major segment. So we can subtract that from area of the circle. Total circle's area minus now area of major segment is equal to area of circle. Area of circle minus area of minor, not sector, segment. area of minor segment. So area of sector pi 3.14 into r square 225 minus area of minor segment 20.44. Now calculating this, we will be getting 314 into 225, 20 remaining to 7, 15, 8, 2, 6, 8, 2, 6, so 0, so the product is 70650. After 2 digits keep a dot, minus 20.44. 706.50, 20.44, subtract this, 6 times 0, then 6, 8, 6. So 686.66 centimeters square. This is area of major segment. Area of major segment. Subtract area of minor segment from circle's area, you will be getting the answer. Next question, a car has two wipers that do not overlap. Each wiper has a blade of length 28 centimeter and swipes through an angle 120 degree. You know that in car, this is the portion and the wiper will move like this. This is one wiper position. This is another wiper position. The wiper length given 28, both 28, and the angle covered by the wiper is 120 degree. Find the total area of area cleaned at each sweep of the blade. So area by the blade, that angle and that is in this shape of sector. So 120 by 360 into 22 by 7 pi r square, 28 into 28. So this is 4 times, this will cancel, 12 3s are 36, then we need to multiply 22 into 28 into 4 divided by 3. Area covered by a blade, don't say the blade, by a blade. 2 blades are there, so a blade. One blade sweeps the area, this one. Now 22 into 4, 88, 88 into 28, 8 8s are 64, remaining 6, and 64 70, so 2464 by 3 is equal to, divided by 3, 8 times, and 2 times 6, 1 time, point remaining. So it will goes on. Look at here, 2464 divided by 3, 8 3s are 24, 6 2 3s are 6, then 4, 1 3 is 3, remaining 1. After keeping a dot, we will be having 0, 3 times 9, then again 1, 3 times 9. So rounding of this, we can take 8 to 1.3 centimeters squared, but we need to find for 2 blades. So area blades is equal to 2 times 821.3. So 6.2416 centimeter squared. So 1642.6 centimeter squared. Seventh question. A chord of a circle of radius or subtends an angle 60 degree at the center of the circle, so that the area of the corresponding minor segment of the circle is equal to pi r squared times 1 by 6 minus root 3 by 4 pi. So, chord of a circle, this is the circle. Now we will consider one chord, a chord AB. Now this chord subtends, what is given, a chord of a circle of radius r subtends an angle 60 degree at the center. Now this chord subtends an angle 60 degree at the center. So we will take chord AB. AB is a chord, O is the center, and angle subtends at the center is 60 degree. Radius of the chord R, radius R, angle 60 degree. They are asking us to find the minor segment of the circle. Show that the area of the corresponding minor segment of the circle. So this is the minor segment. So we know very well area of the minor segment is equal to area of the minor sector minus area of the corresponding triangle. So we know very well here. Let's consider the triangle. This is the triangle. Angle is 60 degree, and this is also R, this is also R. These two sides are equal, means these two angles are equal. So these two angles are equal, A and B angles are equal because O angle is 60. 180, total angle sum of the triangle is 180 minus 60, we will be getting 120. Dividing 120, because A and B are both equal angles, we will be getting angle A is equal to 60, angle B is equal to 60 degrees. So ABC is an equilateral triangle. Now area of the sector, we will find separately area of the sector first. Sector radius here given R, angle 60 degree. So area of the sector is equal to 60 degree by 360 into pi r squared. In our answer itself pi is there, so no need to replace any value for pi. As it is, we can keep. Look at here, we need to show the answer with pi. So no need to substitute any 22 by 7 or 3.14 anything for pi. We can keep as it is. Radius is r squared. So when we are cancelling this 0, 0 and this 6 times, 1 by 6 pi r squared, we got area of the area of the sector. Next, we need to find area of the corresponding segment. For finding that, we need to find area of the triangle. Area of the triangle, triangle OAB is an equilateral triangle. So OA is equal to OB is equal to AB is equal to R. So we know that area of equilateral triangle is equal to root 3 by 4 side squared, A squared. Here our A is R, radius. All the sides are R. And OA is equal to OB is equal to AB in equilateral triangle, everything R. So we can replace R squared. Now finding area of the minor segment. Segment is equal to area of the sector 1 by 6 pi R squared minus root 3 by 4 R squared. So if we are taking R squared, here R squared is common. When we are taking R squared outside, we will be having pi by 6 minus root 3 by 4. But in our question, they took pi, they are asking us to prove that pi R squared times 1 by 6. So take pi also common. When we are taking pi common, throughout divide that by pi, multiply and dividing one pi. That is multiplication pi we are keeping outside. That pi R squared pi, we are dividing each term by pi means 1 by 6 minus root 3 by 4 pi. We are taking common outside. Square units. This is the area of the segment. What is the question they are, what is the answer they are asking us to prove? Like that we can give the answer. Next question, an equilateral triangle inscribed in a circle of radius R, show that ratio of area of the triangle to the ratio of circle is equal to root 3 by 4 pi, approximately 0.413. Now look at the diagram. Circle, a triangle inscribed in a circle. So we are considering this a triangle inside the circle. Now take the circle's vertex ABC. This is A, B, C. Now ABC is an equilateral triangle. So we can consider all the sides as A. If this side is A, this side is A, this side is side length of. So in triangle ABC, we are taking side AB is equal to BC is equal to CA is equal to A units. We are considering side length A units. Now the circle's center is this. O is the center. Radius is R. So if we are joining OA, OC and OB, we are getting the radius because ABC on the circle. So OA is equal to OB is equal to OC is equal to R units radius. Then area of the triangle, we have to find area of the triangle. So if we want to find area of the triangle means we need the height. So height from C to, if I am drawing a perpendicular line here from the vertex C to AB, if I am drawing the perpendicular, that is the height of the triangle. Yeah, we got the height here. Now consider this This is the height of the triangle. Say that point, the meeting point is D. This point, D point. And here we are having O. Here we are having O, this is D. So what happened if the center is there now? Now in an equilateral triangle, the height and median both are same. Now CD is the height of equilateral triangle ABC. Since it is equilateral triangle, that is nothing but median of triangle ABC. In equilateral triangle, height and median both are same. Now this is R. O to C is R. The rest of the part OD we don't know. C to D is a median. A to BC also we can draw a median. See, this is the equilateral triangle CAB. From C to D, if we are joining the midpoint, that is the median. A to BC, if you are joining the line, the E is a midpoint, that is also median. F is a midpoint, this is also median. All the three medians are meeting each other. That is nothing but centroid of the triangle. Now here the circle's center is the centroid of the equilateral triangle. So the ratio of the centroid is 2:1. CD is the CD divided by the centroid point O, that is OC is to OD, nothing but 2:1, because O is the centroid, meeting point of medians, meeting point of all the three medians, nothing but centroid. When a circle, when a triangle inscribed in a circle, that circle center is nothing but the centroid. So it will divide the height into 2:1. Our CD divided by OC and OD in the ratio 2:1. So CD totally 3 parts are there. OC having 2 parts and OD having 1 part. So if I am writing this, that is OC divided by CD. Out of CD, OC is nothing but 2/3. Total parts 3. Out of that, OC is 2 parts. If we want to if we are cross multiplying, 3 times OC is equal to 2 times CD. So our CD is nothing but CD is equal to, divide the 2 that side, 3/2 OC. What is our OC? Our OC is the radius. So CD is equal to 3/2 times radius. So this is one point for the equilateral triangle. The next point for the equilateral triangle. Next, in an equilateral triangle, this is the equilateral triangle, and CAB, we are taking the height D. So I told A units, all the sides are A unit, D is the midpoint. So AD is nothing but A/2. So because the height is nothing but median of the triangle, so D is the midpoint of D is the midpoint of the triangle. In triangle ABC, D is the midpoint of AB, which means AD is equal to A/2 units. So using this, if you are calculating length of AB, that is nothing but so what is our length of AD? Using the Pythagoras, we can find length of CD. CD is equal to hypotenuse square, square root of hypotenuse is a squared minus, that is consider the triangle. In that equilateral triangle, we are going to consider only this part. Both the sides we will be having equal area triangles, because median divides the triangle into two equal parts. This is A unit, this is A by 2 unit, here 90 degrees. So we are applying Pythagoras. So in triangle ADC, the CD length is nothing but square root of hypotenuse squared minus one side squared, A squared by 4. So CD is equal to, taking LCM, 4A squared minus A squared divided by 4 is equal to square root of 3A squared by 4, which is equal to, A squared and 4 are square numbers. So we can take A root 3 by 2 units. A root 3 by 2 units. So take this is first equation. This is the second one. Comparing 1 and 2. Here also both the place we are getting CD. CD we got A root 3 by 2. So comparing 1 and 2, what we are getting? Eighth question. An equilateral triangle is inscribed in a circle of radius r. Show that the ratio of the area of the triangle is to the area of the circle is equal to 3 root 3 by 4 pi, approximately 0.413. So here given a triangle is equilateral triangle inscribed in a circle. To prove, we need to prove here area of the triangle is to area of the circle, which is equal to 0.413. Ratio of the area of the triangle and area of the circle is this one. That is the thing we have to prove. Let's see that one. First take a triangle which is inscribed in a circle. So circle, one circle is there. Inside this circle, we are having triangle. So a triangle inscribed in a circle means all the vertices should be on the circle. All the three vertices should be on the circle. That is the. So here a triangle is inscribed in a circle. Let's take a triangle's vertices are ABC. This is A, B, C. So this is an equilateral triangle. Now we are having a triangle which is an equilateral triangle. Say the side A, AB is A and AC is, because equilateral triangle all the sides are equal to A. Now to prove this we need to find the area. Area of the equilateral triangle we know very well, that is area of the equilateral triangle. Equilateral triangle area root 3 by 4 A squared, and circle's area pi r squared. So one unit in A, another unit in R. We cannot find the ratio. So what we need to do, we have to take our A in terms of R. A is equal to what are R's? How many R's, like that? What is the relation between side A and the radius? Here it is given the radius of the triangle is R. So if you are taking, this is the center of the circle, then O is the center of the circle, the radius OA, OB, OC is R. This is O. O means R. So we cannot find the ratio. We need to find A in terms of R. For that, what we are going to do, we are going to take the triangle separately. Now the same triangle, I going to take it separately. Look at here. First, the triangle, same equilateral triangle. Now this triangle is inside the circle. We are going to find what is the relation between A and R. For that, separately we are taking. This is A, this is B, this is C. In an equilateral triangle, if we are dropping the perpendicular line, we are taking a perpendicular line, that is the height of the triangle. From A to BC, I am going to drop a perpendicular. That is the height of the triangle. Now AD, if I am naming this D means AD. AD is the height of the triangle. In an equilateral triangle, height and, if suppose take this point as D, AD is the height T. So this is height of the triangle, perpendicular. As well, in an equilateral triangle, very particularly, the AD is not only the height, that is the median, that is the D is the midpoint of BC. Only in equilateral triangle, the height and median both are same. So in equilateral triangle ABC, AD is the height. AD is the height. As well, AD is the median. So first we are going to consider this is the height, and we are going to find what is the height here. So we took this is A and BC is A, means B is the median. So BD is A by 2. Using Pythagoras theorem, in triangle ABD, the length of AB is equal to square root of, AB is the hypotenuse, square root of A squared minus A by 2 the whole square, A squared by 4. So AB is equal to, we need to find AD. Don't find AB, find AD. Anything, AB already A. So find AD. What is the height? What is the height? We are going to find here. Our height AD. So AD is equal to square root of hypotenuse squared AB squared minus another side square BD squared. So AD is equal to square root of A squared minus A by 2 the whole squared, A squared by 4, which is 4A squared minus A squared by 4, which is equal to 3A squared by 4. When we are taking A squared and 4 out of the square root, we will be getting A by 2 root 3. That is A root 3 by 2 units. That is our height. That is AD. So here we got AD is equal to, one answer we got, AD is equal to A root 3 by 2 units. Remember this. Now the same equilateral triangle again we are going to take, and what is the median we are going to find. Now the triangle which is inside the circle, again we are taking separately. Now this is vertex A, B, C, and taking the perpendicular from A that is our median also. So previously using median we got one answer. Now we going to previously using altitude we got one answer. Now we're going to use our median concept and we're going to find another relation. Now AD is the median. In equilateral triangle we can draw three medians. A to BC one median and B to AC another median and C to AB another median. This meeting point of median is the centroid of the triangle. This meeting point of median is the centroid of the triangle. When this triangle inscribed our circle, look at here, this triangle inscribed our circle, the centroid is nothing but center of the circle. This is the centroid. This O is the centroid of the triangle. O is the center of the circle as well. O is the centroid of the triangle. So we are having O here. That is the centroid, meeting point of all the three medians, nothing but centroid. Centroid will divide median in the ratio 2:1. So here in triangle ABC, AD is the median, then O is the centroid of the triangle. Centroid which is divide AD into the ratio 2:1, which means 2:1 is nothing but OA is to OD. Two parts for OA and one part for OD. So AD, totally AD consisting three parts. In that OA by AD is 2/3 parts. OA by AD 2/3 parts. Cross multiplying this 3OA is equal to 2AD. So we will be having, if you want to find AD here, 3/2 OA. What is our OA? Our OA is the radius here. OA is equal to R, OB is equal to R, OC is equal to R. Everything radius. So AD is equal to 3/2 R. So this is another one. So two ADs we got. This is one AD. This is another. Comparing these two equations, we will be getting what is the relation between our A and D. So compare 1 and 2. Both are AD. So A root 3/2 is equal to 3/2 R. So cancelling 2 and 2. We will be getting A root 3 is equal to 3R. What is our A? A is equal to 3/root 3R. Otherwise, side A is equal to 3 can be written as root 3 into root 3. Cancelling 1 root 3, we will be having root 3R. This is the relation between the side of the equilateral triangle which is inscribed in a circle of radius R. So when an equilateral triangle inscribed in a circle of radius R, the side of the equilateral triangle is root 3 times the radius. Now we can find the ratio. Now ratio, what ratio they are asking? Area of triangle divided by area of circle. Area of triangle root 3/4A squared divided by pi R squared. That is equal to root 3/4 into A squared is root 3. A squared in terms of R we are writing. pi r squared, which is equal to root 3 by 4 into 3r squared by pi r squared. R squared cancel. So remaining 3 root 3 by 4 pi. 3 root 3 by 4 pi. So when we are replacing the values, root 3 value 1.73 divided by pi value 3.14, approximately we will be getting the answer 0.413. When you are dividing this, multiplying into 3 and dividing, 0.413 will be the answer. So when a equilateral triangle inscribed in a circle, first we need to find what is the relation between side of the triangle and the radius of the circle. So that first we are taking the triangle and getting height, we are finding one relation. That is, here we got one relation. This is AD is equal to this one. And we are median and height both are same in an equilateral triangle, then we are getting this. Comparing these two, we are getting the relation between the side and the radius. Then we are finding the ratio of the area of triangle and circle. Next question. In a square is inscribed in a circle. A square is inscribed in a circle of radius r. Show that the ratio of the area of the square to the area of the circle equal to 2 by pi approximately, which is equal to 0.110. So area, we have to find the ratio area of the square divided by area of the circle. So area of the square a square divided by pi r square. One is a square, another one is r square. We cannot find. So that we need to find what is the relation between the radius and the side of the circle. So take a circle and consider a square. A circle inscribed in a square means all the vertices should be on the circle. Now this is A, B, C, D is a square and O is the center of the circle. If we are taking O is the center of the circle. When we are joining OC, OD, OA, OB, everything radius of the circles R, 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 R. So we know very well the diagonals of the square bisect perpendicularly. The diagonal property of the square. When we are getting a square, I'll draw clearly and show. The diagonals of the squares are perpendicular bisectors. That is a very important property of the square. Square and rhombus, the diagonals are perpendicular bisectors. So AC and BD are the two diagonals. They are meeting each other at O. This is 90 degree. All the place we will be getting 90 degree. So radius, which means each triangle, we are taking a triangle either ODC or the triangle OCB, whatever it may be, right angle triangle, that is isosceles right angle triangle. So if we are finding the side length, we can take any one triangle. This is R, this is R, this is 90 degree. So AB, side of the square AB is equal to square root of R squared plus R squared, because AB is the hypotenuse, is equal to 2R squared is R root 2 units. So side of the square is equal to R root 2 units. This is the relation between the side. A is equal to R root 2 units. When a square inscribed in a circle, the relation between the side and radius of the circle is nothing but side is equal to root 2 times radius. Now find the ratio of the area. Area of square divided by area of circle is equal to a square divided by pi r squared is equal to r root 2 the whole square divided by pi r squared is equal to r squared into 2 divided by pi r squared cancel. So 2 by pi, when we are replacing pi value 3.14, 2 by 3.14, which is approximately equal to 0.637. 10th question, a hexagon is inscribed in a circle of radius r. So that the ratio of the area of the hexagon and ratio of the area of the circle, which is equal to this. Once again, we need to find what is the ratio, what is the relation between side of the hexagon and the triangle. So take a circle. So if we are considering this is our circle, hexagon, we know very well hexagon is nothing but 6 sides will be there for the hexagon. So we need to draw 6 vertex. 1, 2, 3, 4, 5, 6. If we are joining this, we will be getting hexagonal shape. This is 1. This is the second side. Like this, we need to find all the 6 sides. That's a last side. So all the 6 sides are here. Now we need to find what is the relation between the side and the radius. Here we got the center. See, this is the center O. We can draw 6 diagonals here. If we are joining, these two are one diagonal. Now draw the diagonals. If I am giving the letters A, B, C, D, E, F for the hexagon, AD is one diagonal and FC is the another diagonal and BC is another one diagonal. So this is the center of the hexagon. Now R, these are the radius. Now the total angle at O, the angle is 360 degree, which is divided into 1, 2, 3, 4, 5, 6 parts. So each angle in a triangle, say take a triangle AOB. So in triangle AOB, angle O is nothing but angle AOB. Angle AOB is equal to 360 degree divided by 6 parts. So that is 60 degree. So angle AOB is equal to 60 degree. So this is 60, this is 60, this is 60, 60, 60. Each angle in a hexagon, regular hexagon is 60 degrees. So that is called the that is the equilateral triangle. So all the angles are 60 here because isosceles triangle, no, so all the angles are 60 degree. Therefore triangle AOB is an equilateral triangle. So all the sides are equal. AB is equal to BC is equal to CD is equal to DE is equal to EF is equal to FA is equal to R units. So side length is equal to, this is the relation between the radius and the side of the hexagon inscribed in a radius. So now find the ratios. Area of hexagon divided by area of circle. So what is the area of the hexagon? 6 equilateral triangles are there. So 6 times root 3 by 4 a squared is the area of the regular hexagon divided by pi r squared. We can cancel 6 and 4. 3 times 2 times, which is equal to 3 root 3 by 2. Replace for a, because that is the relation. No? We got the relation A is equal to R. So we can replace that. Pi r squared, R and R cancel. So we are getting 3 root 3 by 2 pi. Replace the values. 3 into 1.73 divided by 2 into 3.14. We will be getting the approximate value 0.827. Thank you.